Welcome grade 12s to my online classroom. This is the first of many sessions we are going to have for this year. We are going to be doing geography together, so you will be hearing this voice most of the time, and you may hear it for some of the subjects, different subjects as well. So I'm happy to meet you guys. I am Mr. P. Muisa, your instructor for this particular subject. I am very happy to meet all of you. I hope you guys are going to enjoy what we're going to talk about, sort of deeply understand geography and see how easy of a subject it is once you get to sort of understand the work that we work with. Now, on our session outline for today, we are having the first part of many, or rather, let me say the first part of 4 of our grade 10 and 11 revision videos. But the focus really of this video is on how can you actually master climatology, because that's the first topic that you guys sort of meet when you get to grade 10. So we'll be looking at how to master climatology and also sort of get the reasoning that we use in climatology, and how did we actually get the information that we sort of teach you in climatology, so that you fully get how the information is collected, how you should really conceptualize or think about the information, and how do you actually apply it when you sort of respond to your questions in examinations. So the first part in our outline says we'll be looking at climatology as a science. So there we'll be thinking about the nature of science into climatology. So we'll be thinking about how is this subtopic of geography really scientific in nature, and how does it being scientific affect how you should sort of work with the knowledge, or think about the work that you'll be doing in this particular topic. The second part then will be looking at the science process skills that we apply in this particular topic. So in that section, we'll be thinking about what are these scientific process skills and how do we actually use them when we are thinking about the difference between climatology and meteorology, how air chooses to behave. So we'll be thinking about states of matter and how are they connected to density, so the relationship between states of matter with density, particularly the air, because climatology really focuses on how air will choose to behave. And then we'll also be thinking about the Earth's energy balance. So please do stay tuned in our lesson for today. So we'll be looking at all of these parts. Let's start right now. Now, as I said, the first part looks at the nature of science in climatology. Now, you must know that climatology is a section of geography that falls under earth sciences. Now, you'll remember that science is a very broad field, right? But as much as it's a broad field, you should know that within science itself, we have social sciences and natural sciences, right? And within natural sciences, what we will have is different sections. We have physics, we have biology, and we have what we call earth sciences. So those are the 3 subfields that fall under natural sciences. And then within the social sciences, we have a lot of disciplines. Under that, we have what's this? We have sociology, we have philosophy, we have psychology, and a lot political science, a lot of subfields under that branch of science. We also have history and we have geography. That's what's important. So what's relevant for us is that we're really focusing on the history and geography sections of it, because we are still at high school level, right? So when you go to university, you'll also study some of the sub-disciplines that fall under the social sciences or the natural sciences, depending on what majors or what degree you choose when you get there. But what is important is that in as much as the subfield earth sciences falls under natural sciences, you must know that that field sort of serves as a connection between the social sciences and the natural sciences, because remember, geography falls under social sciences, right? And the broader field being earth sciences falls under the natural sciences. Now what that means then is that we sort of apply some core ideals or some core ideas of science when we are studying this section of work. And that's the first thing that you guys need to understand and sort of master. I know what we'll talk about is sort of difficult to understand, but I believe if you just listen attentively, you'll get why it's important for you to really know where your climatology topic comes from before you can actually look at the content itself that comes with the topic. So that's what you should really sort of understand for starters, right? And then the second point says knowledge in climatology is scientific in nature. So that's what we really care about. My highlighting is a bit skewed, but it's fine. Now, how is it in scientific? How is it scientific in nature? So maybe that's what you should ask yourself. How is climatology scientific in nature? Now, we use scientific process skills when we want to gather information about how the atmosphere will behave, how your climatic conditions will change over time. And that's how we can deduce that this is scientific in nature. And as the session, of course, progresses, you'll sort of see why am I saying so? Why am I saying it's scientific in nature? And how does you understanding that it's scientific in nature sort of assist in you getting the jinx of what we're trying to teach you, right? Something very important then to think about is that when we think about different subject matter that is scientific nature, we refer to what we call the nature of science. Now, the nature of science, remember, the nature of something is basically looking at what makes that something that we're talking about. So here we are looking at how is scientific knowledge made up. So since we are saying climatology is scientific in nature, so I want us to think about how is knowledge in climatology scientific in nature. So that's what I want us to think about. So when we think about the nature of science, as you can see here, we look at the different elements that come with it. So the first one says the nature of science is imaginative and creative in nature. So what does that mean? It means when we are working with scientific knowledge, we need to have an imaginative mind. We need to be creative. It also says it is theory laden. So it means that it has a lot of theory that comes with it. So we theorize a lot in this field. So in this topic, you learn a lot of theoretical work in climatology and things that maybe we can say they are sort of laws that define how air will behave, how the atmosphere will behave, and all of that. Again, we say it is influenced by social and cultural embeddedness. Now, what it means is that, and hence I will say geography falls under the social sciences, because in as much as we are looking at aspects of nature which will fall under the natural sciences, but we sort of look at how do these aspects of nature affect humans. That's why you are always asked about the cause and effect. In your paragraph question, you'll be asked, how does flooding affect humans? You see, so it has a social aspect to it. So the nature of science puts emphasis on that, and in climatology we look at that a lot to say, how does this system affect humans? And it means then when knowledge uh, about climate was made up, there were some social and cultural influences to it. So that's what we mean. So scientific knowledge will always be affected by the social context of the people and their cultural practices as well. So that's what that aspect means, and we'll look at it in the next slide, of course. And we say it's empirical in nature, and it's also tentative. So when we say it's empirical in nature, we are really looking at how theoretically entrenched knowledge is. So in climatology, we are very empirical. So we look at the underlying principles that led us to coming up with the knowledge. And as much as we look at these underlying principles, you must know that it is tentative. And what does that mean? It means these principles may change, may be subject to change over time, which means they are not permanent. So when we teach you that warm air will always rise, there are instances where warm air wouldn't rise, right? And we can think of an example that was discovered to say, as much as warm air will always rise, but when we have berg winds, which are hot, dry, offshore winds that affect coastal region, we know those winds are caused by an anticyclone, and this, you know, that anticyclone associated with cold air that sinks, right? But as much as it sinks, it is going to heat up adiabatically, and when it does that, it leads to this air being hot by the time it reaches the surface, and you notice that the movement of this air is downwards down the mountain. So we see that we start now being tentative about the information. We sort of understand that it's not always the case where we are going to have warm air rising, and we sort of understand that this warm air or this hot air in berg winds is not normal warm air that has moisture. But this warm air, as much as it's hot or warm, it is also dry, and it is caused by a high pressure system, and hence it will still continuously follow the principles of high pressure systems, if you get what I mean. So that's what I'm trying to emphasize here. So you need to understand that we use a lot of scientific reasoning, a lot of scientific theorizing when we are working with this section, and it's very important for you to understand the underlying principles, especially if you like to master the knowledge that comes with this topic. And looking at the teaching aspect of things, we also think that it's very important for teachers in your classrooms to also teach you this section in this sense, to look at how scientific it is, and what level of scientific thinking is needed for you to fully understand this section. Now, let's just broaden then what we talked about in the previous parts. So I'm not gonna explain everything that you see on the slides, but I'm just gonna focus on sections of it that are really relevant to what we are looking at. Now, the first thing that I would like us to think about is the creativity and imagination aspects. Now, we know that scientific knowledge is created from human imaginations, and we know that logical thinking was applied to that, right? But how does that really help us in understanding climatology? You might know that, as I said in the previous part, when we look at climatology, we're really looking at what you did in grade 10. When you were introduced to all of this, you did the topic, the atmosphere, right? And there you were really focused on how does air behave in different fragments of the Earth's surrounding sphere, which is the atmosphere. We said that the atmosphere is a layer of gases, right? And these gases are layered and distributed in specific ways, and look at that. But what's more important is that how did scientists or climatologists sort of come with this knowledge, even though they can't see the air? So you must know that there was some level of creativity and imagination applied to that. But you must also know that imagination and creativity is not enough. What is more important is that after we imagine to say, oh, we the earth has these perfect conditions because of maybe 1, 2, 3. After we've sort of come up with possible reasons, we start now investigating, doing a scientific investigation. And what does that mean? It means that now we are going to do some observations. And from these observations, we will come up with some conclusions, and that's what we call inferences. So we will build upon the observation to say, oh, this, since we observed 1, 2, 3, it may suggest that this may be behaving in this way. So we make observations and inferences about the natural world. And in all of these stages, of course, scientists have to use their creativity and imagination. So you must understand that what you study in climatology is basically what has come out of scientists using their creativity, their imagination, and looking for evidence to check if their their creative ideas or reasons were actually correct. And hence you will find out that this section is very diagram based, because those diagrams sort of represent what scientists have sort of find out over time. So that's very important. So you must know that, yes, for creativity to really work, there must be some planning done, there must be experimenting, and that's remember, during experimentation you also need to observe, right? And you need to analyze the data you collect after observing. You also need to interpret the data, or infer the data, or infer, sorry, the data, and also need to report the results. So what you study then in your geography is the results that were called from these observations. So it's very important for you to know how the knowledge came to be. And since we've spoken about observation here, let's just get to it. Now, it says here science is based on both observations and inferences. So observations are gathered through human senses. Now, very important thing is that human senses may be subjective in nature, right? Human observations may be subjective to nature. So how you interpret the observation may be based on your social context, your experiences, which takes us to this aspect to say the scientific knowledge is social and culturally embedded. So it is influenced by what part of society and culture are you from as the investigator. So you need to understand that. So that when you study as well, you are able to relate what you are being taught or what you're studying from your study guides, your notes, this video as well, and different resources your teachers are going to give you. So you sort of understand how all of that information, that knowledge you are studying there, sort of relates to what you are studying, right? Or rather, your day-to-day experience. How does it really relate to your cultural practices, what you see on a day-to-day basis? So that's what you need to do for yourself. And if you do that, then geography will be more alive. You will understand fully the work that you do because you can relate it to your day-to-day experiences. So that's very important. Another thing then, I think it's something I've introduced already, to say subjectivity is important because it allows for you to relate what you are being taught to what you you experience on a day-to-day basis. So it says here, science is influenced and driven by the presently accepted scientific theories and laws. So the development of questions, investigations, and interpretations of data filtered through the lens of current theory. And something very important is that this is not unavoidable. We can't avoid that because you must know that when you are working with knowledge, when you are learning something new, you are basically adding on what you already know. So it's unavoidable for us to be subjective. So if we say when it rains, you get floods, your brain will automatically give you an image of a flood because you've seen that happen. So that's what we mean. So personal subjectivity is very much unavoidable, as this part says. So personal values, agendas, and prior experiences dictate what and how a scientist conducts their work. So that's something very important for you to know. It is for you to master this section. So you see, oh, now it's winter, it's cold, and you think about, oh, this is what I was taught about conditions in winter. So you relate that to what you've sort of observed. Hence, we say there is an empirical basis to science. So scientific knowledge is really based on what you've observed in the natural world. So it's very important to that. And you must know that the observations then are subject to change. Yeah, so hence we say scientific knowledge is tentative. So the observations are subject to change. So you must know that it's tentative in nature. And then there's a part about theories and laws. So you must know that science is not permanent, right? For example, we know that for now, the only planet that has been found out to be habitable is planet Earth. But we can say that is subject to change when new information is discovered. So you must know that some scientific knowledge is subject to change always. And something important is that theories and laws are not the same, right? Theories and laws are not the same. So a hypothesis in science may either lead to a theory or a law being accumulated. In simple terms, since we are geography people, we don't really talk much about what a hypothesis and all of that is. But what is more relevant is that when you make observations in nature, those observations, if they've been concurrently been proven to be true, they either are regarded as laws or as theories, right? And you must know that a law is designed to describe relationships of observed phenomena in nature, while the theories are inferred explanations of natural phenomena So they basically measure the relationship among stuff. So a law that we can say it has been used in geography is to say warm air will always rise and cold air will always sink because it is dense, and warm air is less dense. You see, now that's we can classify that as a law, because it's a relationship that has been observed in nature between the two air masses. And another one says where warm and cold air will never mix, but the two air masses can meet. So take note of the choice of words. So the two air masses do not mix, but they meet. So you see, you can say it's a law again to say these two air masses can never ever mix, but they do meet. Yeah, so that's what you should understand. So those are theories and laws. Of course, they are not exaggerated as such, just as they would be if we were looking at physics or life sciences or biology, so to speak. So there, we don't really exaggerate the laws that much in geography, but you must understand the scientific nature of the stuff. So I hope we sort of get what we're looking at. Now, I want us to then move on to thinking about what scientific process skills then do we use when we coil or make up our scientific knowledge. And that is very important for us to understand the scientific process skill that we use. Now, you must first know that a scientific process skill is a thinking skill. Very important. It's a thinking skill. And it's a thinking skill using scientific processes and approaches. So basically, the session today is designed to assist you to know, or rather master, how to think scientifically, especially when you are working with the different topics in climatology. And you must know that these scientific process skills are different, right? You must know first how observation works. So we look at how was observation used when making up knowledge in climatology. You must also know how measurement is done, how important it is in geography to know, or rather to use the correct units of measurement, as you guys will do in synoptic weather maps and weather stations. You must also know the importance of inference, importance of classification, grouping stuff, prediction, which is what you do a lot. You'll be asked. Since then, we've taught you how conditions of a cold front will be, predict how the weather will change in the next 12 hours in Western Cape or in Cape Town if a cold front were to come. So that's where you need to predict. And remember that a prediction may be an educated one or an uneducated one. So an educated one is based on prior knowledge, and an uneducated one involves some elements of prior knowledge, but it can also be just a wild guess of what you think would happen. And again, the most important thing then is communication, how you choose to represent stuff, how you choose to apply what you've discovered. So that's what you need to understand. So let's talk about observation for starters. So now remember that climatology studies the behavior of air. So now I want us to explore how we can understand the behavior of air using scientific process skills. So I want us to think about that. How can we apply these scientific process skills when we are looking at what we study in climatology? The first one or rather the first skill we talked about is observation, right? And remember, observation is done using senses. And what do we do with senses? We gather information about an object or an event. But here now, the event we are looking at is air, right? Or the object, if it's an object that we are thinking about is air. So we really care about how do we perceive air. So if you look at the diagram, then it shows, or rather it's a representation of how air will be represented diagrammatically, and we are sort of thinking about how will air behave once it is heated by the sun. So you see the rays from the sun over there hitting the ground and the water there, and you know that this water will turn into water vapor, and water vapor is a gaseous substance, so it's basically air, it forms air. So we observe now, if the air were to be heated, what will happen to it? If we were to remove the sun and it's now nighttime, what will happen to this air? So observation basically involves that, gathering information using your senses. But then what we really care about is the vertical movement of air. I think that's the first thing to think about. Now, when we are thinking about how air will move, from observation, you'll notice that air may either move horizontal or vertically, but for the purpose of this lesson, we'll just focus on vertical movement of air, which is the up and down movement of air, basically. And what we'll look at then is it possible for us to measure how this air will choose to behave? So remember that measuring involves using standard measures. Yeah, so measuring involves using standard measures. So you need to have certain tools for measuring different objects or events. Now, if we were looking at the air, remember we're talking about the air. Now, because the sun rays hit the air at the surface, if you were to use a thermometer and measure the temperature of the air or of the water rather over there, and you find out that the water there is 28 degrees Celsius, or the temperature of the air in the surface 28 degrees Celsius or centigrade, and up in the upper atmosphere, and you find out that the temperature is 12 degrees centigrade or Celsius. You then ask yourself, what sort of influenced these different changes in temperatures, or the temperature difference in the lower surface and in the upper atmosphere? And we say you use a thermometer to measure that, right? And if you look at your thermometer, it has negative values and positive values, right? Negative and positive values. And you must know that we have a Fahrenheit scale, which is used mostly in the northern hemisphere, countries over there, and we also have a Celsius scale. So in your examination, they'll always ask you to represent temperature in Celsius or in centigrade. So a synonym for Celsius is centigrade. So when I use the two words, don't be confused. I still mean the same thing. Centigrade and Celsius means the same thing. Okay, and for pressure now, we also use a different thing. We use what we call a barometer. So a barometer is used to measure pressure. So you'll see now I've associated two different figures, or I've sort of measured two different figures. So I've measured the pressure of the air and the temperature of the air at different parts. And for vertical movement of air to happen, we need to always measure the air using these different tools And that's how we sort of start understanding how air will behave as influenced by either its pressure or its temperature. Now, since we've determined the two, now we know the temperature is 28 degrees Celsius and its pressure is low in the surface, while in the upper atmosphere the temperature is 12 degrees Celsius and the pressure is really high in the upper atmosphere. It takes us to the inference step. Now, what is inferring? Now, inferring is formulating assumptions. So you make assumptions or you make possible explanations, and you must notice that inference is based on what? It's based on observation. And remember, when you observe, you also measure. So you'll see that these scientific process skills work hand in hand. So it's important for you to know that. So we've found out that the temperature is 28 degrees Celsius in the surface and its pressure is low, and the opposite is true in the upper atmosphere. So now we start making possible explanations. So you notice now that in a way it takes us to us sort of understanding the relationship between the temperature, or rather the heat source or energy source, with water being heated. Because if you notice in that picture, we have the sun heating up that river, right? So what you will do then, if you look at the diagram on the side, it shows us the different states of matter, something you were taught in the lower grades. So we have solids, we have liquids, and we have gases, right? Now, we are working with air, and air is an invisible substance. We know that air is an invisible substance. Now, for you to move from a solid to a liquid, you need to constantly add heat. And for you to move from a liquid to a gas, you add heat as well. Now, to move from a gas to a liquid, it means you do the opposite, you remove some heat. Now, we have water there, and we see that the temperature is 28 degrees Celsius, which means there is minimal evaporation or change in state from liquid to gas happening there. We can't really see it because gases are invisible, right? So evaporation is taking place. So that's one conclusion one can put to say, oh, because temperatures are a bit higher in the surface than in the upper atmosphere, where it is just 12 degrees Celsius, it simply means that there is some minimal vaporization happening, where water or the liquid substance, the river, is turning into a gas. Now, we see that in the upper atmosphere, something is happening. There's some clouds forming up there. And let me just use a pointer there. So there are some clouds forming in the upper atmosphere. And if you look at those clouds, they also send a certain message to say, now, since there is some heat being added to the water substance there, this water substance tends to rise after it has been heated, right? And as it rises, it goes to the upper atmosphere. But now the temperature is slightly lower in the upper atmosphere. Now it means that as it goes up, it's gonna cool down. So what happens now is that we have condensation happening there. Condensation happens. And why does condensation happen? Because we remove some heat. Remember, to move from liquid to gas, you add some heat. To move from gas to liquid, you remove some heat. So condensation happens, and that's how the clouds are formed in the upper atmosphere, due to the gas losing its heat, or the water vapor losing its heat, and you sort of start getting condensation happening in the upper atmosphere, leading to cloud formation, and of course that may lead to possible precipitation. So if you're inferring, you make these assumptions. Oh, because this is happening, it may possibly mean this. So you look at cause and effect. And that's very important to master climatology. You need to look at, oh, because the air is like this, it means this kind of a system will form. Because air is like that, this kind of a system will form. So you need to know how air would behave at different states, at different parts. And then the next skill then is classification. Very important. Now you've inferred, you've made some assumptions. Now you need to classify and order objects and check how good and sort of check how good that how good those conclusions you've made are, and where can you sort of add or in a way improve them based on how you choose to group or order the objects. So that's what classification means. Simply means grouping or ordering objects or events into categories. And remember, you need to have a basis for grouping stuff, so it can be based on characteristics or a specific criteria that you've set up or put in place. Yeah, so that's very, 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 very important for us to think about. Now, looking at our same diagram, the heat transfer diagram. Now, let's look at how can we actually start classifying stuff. Now, you'll see that, okay, now we have an energy source, and that is from the sun. So insolation is coming in to heat the surface. Remember, that's what we call heat from the sun. So the sun hits the ground, and now we give that a name and we call that a radiation. So the sun brings radiation, and what happens when the sun has brought the radiation? And now you'll notice that the air in the lower surface will be a bit cold, right? Based on the observations we've made to say the sun will heat the surface, water, and wind, and this wind will go up, and after it goes up it's gonna cool down. So it means at some point it's gonna get to freezing point, which means at some point this air will come down again, right? So after it has come down, conduction will happen. So that's the category or criteria we put in place. Conduction happens. So conduction simply means this air will get heated up by being in contact with the Earth's surface. So that's what will happen. Now, after it's heated up, since we've observed that warm air will tend to rise, what will happen is that this air will rise, and as it rises, it's gonna cool down. Now, that is the process convection there. So as it rises, it heats up the atmosphere, and it sort of cools down, and that's what we call convection. So those are the sort of classifications you can put in place to sort of understand this section of work. And then it takes us then to prediction. Where how does prediction come to the picture? So by definition, we say prediction is guessing the outcome, the most likely outcome of the future event based on what? Based on a pattern of evidence. Remember, in science we deal with evidence. Yeah, so based on a pattern of evidence. Now, what you must understand then is that to study how air would behave in order to create different climatic conditions, the prediction process is very much involved for that. Now, we have two fields that assist us with the prediction process. Now, remember, we've took it step by step to say you would make this observation, and then you will use a thermometer or a barometer to measure how air is at different parts of in the surface or in the atmosphere, and then you'll sort of infer or make possible conclusions or explanations of what you've observed and measured, and then you will do what? You'll move on to categorizing the information and coming up with possible plausible categories or groupings of what you've observed. And what you will do then is the last step, predict based on what I've observed and inferred. These are the conclusions I can put in place. And that's why we have meteorologists and climatologists. So meteorologists and climatologists are not the same people. So a meteorologist will study weather over a short period of time. So they'll make these predictions on a daily basis, while a climatologist will look at these patterns over a long period of time and come up then with their predictions to say, based on my predictions over this period of time, these may suggest that warm air will always rise, cold air will always sink. And when we have a lot of warm air rising, for example, in the ocean, then a tropical cyclone will form. So it's based on observing over a long period of time that we can come up with those conclusions. Again, we have some examples here to come up with seasons in relation to the years and the effects of human activities on climate leading to climate change. One has to, in a way, predict or use the prediction scientific process skill. And some of your questions in examinations expect you to follow up to use all of these scientific process skills for you to pass your exam. Observe what is being depicted on a picture, measure certain things, especially with map work, and infer or give us possible explanations of why things are like that. And the next thing then is to give us some predictions where you really apply what you've learned on certain aspects of phenomena, and also give us categories of stuff. How are conditions in a low pressure system? How conditions in a high pressure system? How does warm air behave? How does cold air behave? What's the difference between a mid-latitude cyclone and a tropical cyclone? How is it different from the Kalahari high pressure? You see, high pressure system, low pressure system, all of that. So you are expected now to give categories. So all of these scientific process skills are very important for your examinations because they serve as underlying underpinning principles of assessment that are used for you guys in your examination. So very important for you to master. So now we talked about a meteorologist and a climatologist. So a meteorologist is someone who will study weather on a day-to-day basis. So for example, reporters at ENCA that give you weather news every morning are what we call meteorologists, because they basically study how the weather of the day is. They predict the weather of the day, and it's based on what? Based on them following this whole process of scientific process skills for them to be able to predict how the weather will be on that particular day. While a climatologist then will look at how the weather changes over a long period of time. So, and you'll see now there's a difference in how they represent stuff, right? Yeah, so climatologists will look at all aspects of matter, so and include them in their explanation of what happens in the natural world, while a meteorologist will really sort of care about how the specifics, or rather will care about the specific, how the natural phenomena are arranged and how they affect that particular day, without really looking at what other many systems are in play, as observed over a long period of time. So they really look at what will happen in a short period of time and what is there influencing what happens. For example, we have a coastal low here, so it may suggest it's feeding us with this cold air in the west coast, and that is what is being depicted only there. So one element is being looked at, while with the climatologists they'll put in all the possible elements that may influence how weather is on the day. We have a thermal low, we have a coastal low, we have anticyclones as well, we have ocean currents being represented in the different oceans. So it shows us that a climatologist looks at broader stuff based on observations over the longest time. So very important for you to understand. The prediction process is a complex one, but it becomes easy if you have applied all the other scientific process skills. So in exams, you are expected to make some predictions based on what you've learned. So very important for you to understand. Now, after predicting and all of that, you need to communicate the information you've received, right? And you must know that the communication process may use words, it may use symbols, it may use graphics to describe an object, action, or event. Now, looking at this, the diagram here is basically communicating something to us. So at first, you might have not understood what it was communicating, but after extrapolating step by step what it means, you sort of gotten what it actually is trying to tell us, and the focus was on the vertical movement of air. So you must understand that in climatology we use different ways of communication. We use words. Yes, we do use words. We do use symbols. We do use graphics to represent different stuff. Now, if you look at the diagram, the side, what is depicted on this diagram may be represented using a weather station, and a weather station basically represents the conditions over there. Now, the sphere here is representing cloud cover. So you must know that when the sphere is shaded fully, it represents overcast skies, right? And that's exactly what we have here. As much as we have the sun, but on this section of the picture we have some cloud cover. So if one were to sort of dissect the picture into half and show two representations, you'll see that this picture on the side has cloud cover, and we can say it represents overcast skies. And one may come and argue to say this is possibly 1/4 conditions or cloud cover being experienced. That may be accepted as well, but yeah, so the important thing is that you must know that we use symbols to represent stuff. Now, we also represent the temperature in the weather station. So you might see that the temperature there is 28 degrees. Sorry for that, let me just fix that. It is 28 degrees. So that's the temperature we have over there. We also have the dew point temperature being 12, which is do you remember dew point temperature is the temperature at which condensation starts. Now, condensation happens up in the upper atmosphere, and we said the temperature there is 12 degrees Celsius. So that's the temperature in which condensation starts. That's how clouds are formed. And we have a dot there, and the dot represents rain. So that's a symbol for rain, right? So very important for you to take note of, and that's why we have some rainfall over there in our diagram. And you must know that the feather-like structures there are representing the wind speed. So we have a longer and a shorter arrow there, so that is 15 knots. So hypothetically, yeah, that will be the wind speed over there. And you must know that the direction of that stick is representing the wind direction. So if you look at it, that direction is towards the north. So we have northerly winds there. And the last symbol, which is the H and the L, represent pressure. So those are the symbols we use, guys, that you must know, that we use for communication. Now, the most important question then is that how does all of this information help us? How do these help us? How does you understanding all of this process help us? Now, what is important for you to note is that understanding these scientific process skills enables you to be able to apply the knowledge in different situations. So you show and enhance understanding of the scientific processes. Now, you must note that through understanding these scientific process skills, we are able to experiment over and over again and prove the level of applicability of the gathered knowledge. So typical example is that in the previous diagram, we were explaining how convection, conduction, radiation works, right? In relation to the air. Now, you can take a matchstick and light it up. And as you've lit it up, you can actually see that it actually we also have that process being applied. So you see now the fire from the matchstick is now the source of radiation. You see that now, and you see that the air in the atmosphere around this matchstick will be in contact with this matchstick, and after it's in contact, it gets heated up. So this air will be cool. It goes there. After it's heated up, it's going to rise, right? And convection happens. So conduction happens when this air is in contact with the matchstick itself, and the person holding the matchstick as well. As it burns, they may get to a point where the fire burns their fingers. So it's perfect representation of how conduction will happen. So transfer of heat through physical contact. So person will get burned. So that's that. And convection will happen as this warm air goes to the upper atmosphere and cools down. So that's what you need to understand. These scientific process skills, they assist us to master science, master the thinking behind science. So very important for you to understand. Now, let's summarize then. So in summary, to master climatology, you need to think like a climatologist. That's the first rule. You need to think like a climatologist. And as we said, climatologists are scientists, right? So you thinking like a climatologist entails you thinking like a scientist. So it means you guys are scientists as you are doing this topic. Now, thinking scientifically means now you need to be able to use your scientific process skills or your science process skills. And remember, your exams questions, all your exam questions are always based on these science process skills. You are always expected to apply them as you answer exam questions. Now, and another important thing is that it is not important to just know the stuff. What's more important is that you understand the stuff. You need to understand the work you do. Now you need to understand this section, and for you to understand it, trust me, for you to master this section, always approach the work using the scientific process skills, because understanding the work enhances your reasoning, and if your reasoning is enhanced, then you can think about the work in an effortless manner, really. So it's very important for you to do that, and always use your symbols, right? Because remember, your symbols assist you with reading the information. So when we give you a synoptic weather map, for you it should be like a book. You need to understand everything that goes on there. And when we ask you to represent the knowledge, you need to use the relevant symbols that we've taught you for that work. Now, you need to study diagrams to identify the characteristics represented. And remember, in the diagrams, we may use the symbols that we have said are very important for the section. And the most important one is that you must always remember to apply the climatology golden rule. So there are certain rules that we attach to air, or how air will choose to behave, that you need to understand, that you need to always remember and apply for you to master all of climatology, or master the section and get a total in your examinations. So that's it for today's session. Thank you very much for tuning in. Look out for session number 2, where we will be continuing with our grade 10 and 11 revision. That session is going to be on the climatology golden rules that I said you guys need to always remember and know how to apply. Thank you very much for watching. Thank you very much for listening in. I hope you took some notes, and I look forward to having you in more of our online classroom sessions. This is Mr. P. Mbuisa again, speaking with you. I am signing off. Thank you very much. See you in the next session.
Audio Jungle.